So I was thinking about slope angle for pi, right? Because like in order to solve for pi, like this is a whole thing effectively. When it comes down to like we use vertices of points to points for every single point along a perfect circle for that kind of thing, right? But like you can use a slope only as a result of calculating on a grid line, which gives you exactingly these things, is what you think. But like two intersecting slopes then give you exactingly the same thing, right? Or multiple intersecting, circles, effectively. They give you a point that's exactly right there, like a three-dimensional tensor vertice, right? And so when you know that, it's like, oh, okay, well, that's pretty simple. You just have to make sure that that slope intersects there. And depending on how you decide to do it within your version of how that works, because that's a relative problem of perspective in math, because like this is grid layer math paper slope blah 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 with this lines. You know what I mean? Like these lines line up like this kind of thing. So it's like, oh, okay, but we only want the 1 millimeter versus the 2 millimeter or the 3 millimeter squares. Okay, but like meanwhile, my mind goes to, so the programmers who originally programmed the math behind this also say that everything starts at the start of 0, but the math only starts at 1, which is its own problem too, in a lot of ways, for what it's worth, because I don't really want to get into that too much more either. But the point is, it's like slope angles, you can't calculate slope angles without having a grid line. It's like, why? What are you talking about? You can use anything for a grid line. If it's a known constant value, meaning this circle, right, which is, let's say it was a diameter of 3 millimeters, fine, whatever, right? But it's a not perfect circle. They're all exactingly this type of specific oval that is super not pi. Right? Like it has this little angle or some other wonky bullshit to it that fits in because puzzle piece and go fuck yourself now. Right? Because I wanted to. And that's all you had to do, right? Like here's a weird wonky, it's straight enough, I guess, except it's a part of this over here, intersects there. So it's not, I guess, straight anymore. And it's like, behold, now I have slope angle without ever needing grid line. It's exacting value, slope angle. You could also use it with perfect circles that use pi, I guess. But it's like, if you use that, okay, then it's like, okay, well, every single point in vertice point, right, then becomes its own curvature point, right? But it's like, all right, but then that flows into, when you get to the correct, slope, effectively, of many of these different circles, to the point where all of them line up to being pi. Exactingly, highly finite. There's one vertice now, pi equal 1 now. But you can't do that. You're not allowed to. That's the thing. In the world of math, it says, no, that's not allowed. And I went, do it anyways, I don't care, fuck you. You don't control my scribbles of various numbers. I will scribble harder now, you cannot stop me. I will play with anything I want. You're not allowed to, says you over there. Right. Meanwhile, the real answer and truth of it is like, well, you don't have to use a straight line. You never do. Ever. Not once do you ever have to use a straight line. to calculate for a curve. And that line that is not straight can be multiple different intersecting curvatures that make up one single straight to its view of events line. Isn't that fun? It's like, hey, this is basic math that you were taught in like probably middle school or something, for what it's worth. And all it is it's a straight line. But what you're using is technically trigonometry and calculus together to go, hey, I did this with other lines that started at different points. And I made different sizes of them that have different curvatures, mostly as a result of this Z and topographical like curvature. Except every time it happened to try and move, it actually only just continued in a flat plane, even though it's irrespective of the derivative start of their perspective. So the relative sensor data, if you will, of your view, perspective, of where you started, says that this is what this was. Right? Like this is looking all on the up and up, straight, all good, nothing wrong, everything's great. Right, that kind of thing. But you've been actually constantly turning. You don't know. There's no force applied except for exactly straight. It's all normal. Everything looks flat, you know, background-wise. And there's no curvature. Certainly no depth either, somehow. And yet, suddenly, hey, wouldn't you know it? You're back where you started. You met some people along the way, they influenced you, talked about this, blah, 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 yada, yada, fuck, squeeze, bang, blow. Yeah, that kind of standard stuff. Right, you went up over there, you went down over that way, you traveled over there. And yet you ended right back to where you started. Isn't that interesting? You know, as a thought. Isn't that an interesting thought, right? Yeah. But it's like, hey, guess what? That's velocity, right? It looks very similar to velocity. And it's like, you're right. The velocity remains at zero. And yet you did do something, and yet things did occur, and within that you have a perfect circle. You looped exactingly this amount to exactingly where you started from. And you have perfectly finited a given perfect circle. I went and did some other ones, to be fair, just to figure it out. Like if I could do it other ways. It's like we're talking about slope angle here. And it's like, you're right, that is still slope angle. It's just that that's how dimensional math works in a lot of ways. Not that I knew that at the time. I was just working on it in my head for a while. I was like, oh yeah, well, and then my fucking middle school teacher told me velocity can go back to being zero if you arrive at the same point. That's a thermodynamics p-value. And like you're spinning on the Earth, you know what I mean? Well, then that's rotating around galaxy thing. You know, so like you can never really quite ever have a real velocity equals zero. But he was one of those teachers where like, you don't know that. You know what I mean? And it's a relative equation, right? So like depending on the scope of the bubble that we're talking about, we're talking like, hey, guess what? If in our own atmosphere and then you traveled exactly, and then you land and all that, your velocity is basically zero, right? And it makes sense because that's to get it into your head, right? To help you understand something, right? However, then you get older. Well, he was not fully correct though. You know, like, teacher, this is a thing, right? This might not have been what you said it was. Anyways, though, moving on. Good enough. I got the idea. I got the knowledge. I understood what you were putting down, but still, I have to remember this for this stuff now. All right? Meanwhile, universe, hey, our single point that it all arrives at when we measure. Oh no! There are telescope inaccuracies here in our measurement and math data. Uh-oh. I'm like, all right, well, I have to help them understand the math. How would I do this then for them? Because they're slow. They don't even want to watch the video. So I moved on to like thinking about that stuff. Housing situation hasn't got better. So moving on from that, let's go with like regular flat vertices, flat land stuff that nothing is ever actually like that, and just because we view it in these flat windows, that then clock cycle forward, that doesn't actually translate to real world anything in any thermodynamic moving third dimensional sense of multiple points of quantized energy and movement, parameters of rough values that eventually work out to becoming like a total P and Heisenberg got broken value. Which that one's kind of sucky, right? Like, hey, Heisenberg was right, but only to a point. Only to a point. Unfortunately, we're fucking with that when we look at that. That one's kind of weird, isn't it? We are. When we look at it, we're fucking with it. That's what he's trying to say, right? But it's like, yeah, I know, but we could fuck with it where we know what we're inputting and what that could be doing, right? We can calculate for possibilities and probability factors, but also we can go with them as it moves and input and take out, like that one video I put out for measuring heat in a given quantized space-time area, added at PBS space-time, I think it was like 2-3 years ago or something. Point is, they never watched it. Nobody ever really did. It wasn't even like 10 minutes, I think. Point is, flat vertices, even though nothing actually works that way, and there's no way that ever is a thing, we have to go with, all right, yeah, I mean, all right, so the three-dimensional paper that's flat to us because it's super thin, with the three-dimensional placement of some marking, but it looks flat to us. With the three-dimensional energy, their N that changes, that moves as well, but looks flat to us because of how we view it. Says that this is a perfectly flat circle that's perfectly round, which it's not, as it's always wiggling and jiggling around. But anyway, can I troll harder? Not really, right? Because it's like, behold, the crux of pi being what pi is. We have to ignore all reality and then come up with a thought experiment that makes no sense. Right? Like, no, it doesn't do that. It's never done this. It never will do this. You just keep lying about it doing something. You lying liar pants. You fire people on fire. But let's go back to it. So it's like flatland stuff is pretty simple stuff usually. But like it's just like, hey, well, let's just not do that thing. Let's think about slope angles being like, well, why do you need a grid for a slope angle? Right? Like that's the first kind of problem, right? So it's like if you think about it in like the context of quantum standard model, so probability math, right? Statistical probability math stuff. Then you have to go, in these rough general areas,
There's a thing. Now, to us, it's rough in general because we're really good. We got, boom, flexes, some skills. We're really fucking good at looking at this thing right there. Really tiny, you can never see it without this. You are piss poor and always being able to do this like us. We are so amazing. That's how it works, you know what I mean? And we move forward. We're like, all right, amazing person. Tell us what's going on. Well, the probability says it's roughly in this area and like this, and it has this kind of energy. And it's doing these wiggle jiggle things, roughly. That means most likely it's like this. It sounds an awful lot like a bunch of maybes that might mean something. What am I supposed to think about this at this point, right? What am I supposed to say here? You know, like, no, you're right, but then I could have said the same. There's maybe roughly a tree over there that's roughly like this, and it's roughly in that area, and it's, you know, basically, kind of like this tree. And, like, you could just do that anywhere, and you'd probably be right. You know what I mean? Right? Like that level of, oh my God, bro. Oh, yes, there's a birch tree somewhere off in the forest over there that's known to have some birch trees. Really? You don't say. Look at that birch tree. And it's roughly like this, about this tall. I mean, this could be, and it's roughly in this kind of local, real area, topographical, tensor-wise, on this hill, mountainside right there, not moving much except for the fact that the Earth is rotating and that's going, so it's moving a little. In fact, it's faster than we generally are, it seems like, you know what I mean? Make like a tree, get out of here, you know. It brings a new scientific meaning to it. We just don't tend to look at it like that relatively, you know. But it's like, all right, well, I mean, that's known to have like a birch area over there, you know, and then there's this tree and it has these spots and it has this thing, you know, all that stuff, right? And he's like, all right, yeah. So you were able to go over there and look at it? Yep, and that's the one. That's what they were looking at. Oh, okay. How'd they go over there? What is this? What is this witchcraft you speak of? There's very small things. The symbolic, look, the analogy symbolic thing here is very frustrating. We can't just drive and see the tree that is the particle. That's true, you know, that is kind of hard to do, I suppose. Yeah. Be a weird one, right? We'd have to get some people nearby. They'd be like, hey, I'm trying to get the wind to move the right way, and then keep that kind of still area for that, move the leaves out, and maybe I'd get a little higher for, you know what I mean? Maybe, you know, something like this. Maybe if I fucking force this kind of light wave through that then can only interact with this stuff this way, and we're pretty sure it means this, except it definitely changed it as a result of introducing a lot. I mean, it burned maybe the tree. Yeah, I see flames. That's not good. That's really not good. All right. Well, it was likely. I mean, we captured the light though, and it said it was there. It's not anymore, but like it was. Maybe if you freaking throw some water. Oh yeah, no, cool it down. Okay, yeah, no, yeah, all right. Well, you know, it's a burned birch tree. It has changed its mass, its energy levels. Many things have gone down. We are uncertain about some of this, but we knew that there was for sure likely a birch tree. Although scrubbing through some of this information, there were a lot of other trees. They clearly changed those results too along the way. And the position of the person receiving the light wave was not perfect, and also altered what it saw as it came in, because, you know, it's like that. It isn't perfect. There's other light waves in the area. You know what I mean? Can't get rid of them. They're always talking about this noisy data. Light emittance coming on. Oh, leave that lizard alone. Oh my goodness. Come on, it's okay. Yeah, leave that horn. I think it's a dead horn. You would have ran. Yeah, he's a fat, bloated motherfucker. All right, come on. Good boy, Phaser, come on. Anyways, yeah, good old forest. You're just walking on a trail. Recently did, most likely. Yep. Saw one over in Park once. Anyways, yeah, no, that's the thing over there. So, anyways, talked about like back in Chandler, how I'd say that there was a lizard a dog would find, show me a trailer, this very trailer actually. That's a very deja vu thing. That's like over a decade ago. Deja vu, man, is after a while. Anyways, but point is, it's like, all right, so vertices here, right? Except they're not, right? But it's like, no. See, that's where you're wrong. You need to intersect graphs. No, I don't want to do that. That's not allowed now. I can't just bloom it to all of these other graphs that I can make p-value exactingly these things for these lines. There's a lot of graphs. Really? So you can't assume that it'll continue traveling along this slope? Well, no, I can though. Yeah. So the circumference pi stuff, right? You can't assume that it'll continue on like this. You have to have p-value every single spot, right? Well, it's funny. There's enough right angles to get to the apparently near infinite possibilities to the end of this inside of a sphere. When you get there, though, then you get all other given possible right angles, and then from there you get all other angles, kind of like Vsauce. Just talked about what it's worth for that given equation. And it's like, but true. Wait a second. You know what I mean? Because like I imagine that would be like you guys, right? Because it's like, well, yeah, but that doesn't sound like anything. It doesn't, does it? Right? At first, till you realize like, oh wait, contained within this information, there is a point with which you can absolutely get all of the information. It's a P. No matter how hard you try, it's finite. But we're really bad at doing that. Really, we're looking for a cheap, fast fucking way to do it, right? And we're like, we refuse to ever introduce any slope angle to perfect circle. Why? I told you multiple times it's slope angle. Just use a slope angle. What are you fucking doing? Why don't you just use your fucking slope angle for your math? Why didn't you introduce that? It's like the most obvious problem ever. Just slope angle it. You know it's projected to continue on like this. Just use your slope angle. That means you know damn well what the fucking actual circumference of pi is. You just need to now know diameter every time. Just use slope angle. Why don't you ever use slope angle? You learned this in middle school. Here's my grid line, it goes outside, I then do this. Oh, and then I do it inside, and I intersect them at a vertice point along the circle. And then, oh my gosh, from that one to another one, it means this slope angle. Which then means no matter what, the circumference, only this, exactingly. Why don't you just be practical about it? What's your math doing wrong? It's assuming a bunch of bullshit. When you look at how they calculate for pi, it's really stupid. Like, wait a second. It has to curve like this because there's all these point. Slope angle. It's a ray that you bend. Rod that you bend. Oh my God. Why is this hard for you? Dude. Why? You do 2 points, you go, it's a ray, and then you go, I combine all of them, and you can use any number of amounts that you want. Use a slope angle. Fuck polygons anymore. We don't use polygons. We use slope. We use literal lines and points. You just curve them with a slope angle. Fuck polygons. Fuck tensors. Fuck geometric. Fuck all of that. Fuck dimensionals. No offense. Because like, oh yes, no, I mean, there's so many. You only need, well, here's dimensionally speaking, how you can use the slope angle just the same to map all of that the same. No longer do you have to have every single paper. You can automatically know that it should be like this. If this is what you're stating it should be this. Instead of it going up, down, left, that's a relative perspective of other things coming in and going through. That's energy quantized relativity style. Now I remove all of your little infinitely small, thin windows, and I say, here, do this. Do it three-dimensionally now. Make a sphere. Here's all the given infinite possibilities for all the different directions you can take, immediately known, because you used slope angles for once. You should have learned that in middle school. Why is this hard? These are just rays, bitch. You move this long and I moved over here now. I primed your ass earlier. You thought I was just lying and all that. Trying to get you kept around. And wouldn't you know it, slope angle. A change of the given speed and energy, movement of information. Yes, the material properties, yes. Hey, slope angle change. Distance of the ray and point-to-point changes. Oh no, I have so many of them though. Look how many that I can calculate automatically as I continue along with them and relay, hi, this is me. Yeah, nice to meet you. Hi. Yeah, so we're doing it. And then, but like we're trying to get this done. And dancing and fuck, squeeze, bang, blow. Boom. I don't know. Changes of the energy, the direction, the information. Huh? Come on, keep up. You should already know what your sensor is, the energy you're putting in, the energy roughly of the system as you continue on, as you change, as they dock and try and equalize as a fundamental force of entropy that is a particle as well as a wave in field. Also happens to have a force carrier. But anyways, thermal is not a, I relay information to you. There's some loss. Yes, because that person heard me over there talking about how I was going to fuck you. And they were all jealous. Meanwhile, we still fucked. Stay jealous over there, bitch. Get wrecked. Don't care. Doesn't matter. Moving on. And that's what that is. Literally, behold, it's you as people interacting. Yes, quantum thermodynamics and injury and all the rest, really, in fluid dynamics for what it's worth, which, by the way, we model that all the time. This fucking sucks to know, because it's like, and you doubt me? A mosh pit acts like a fucking combusting exothermic gas. You know what I mean? Like, what is this? You guys act very similar to fluid dynamics in a thermodynamic way, using quantum informational and field dynamics, which means they're intricately linked, and in fact, you can't get one without the other. Momenta, which is what all energy is based off of, meaning movement, is what you say. Like, it's like absolute zero means no movement. No. Relative is what you're saying. If you account for all the little wiggle and jiggles of all these big and small phenomenon where you're trying to get this to line up just right for this absolute value bullshit, then yes, but it's still moving with you as it rotates, and then that rotates, and then that also is also going and orbiting around, of course, a black hole, and then that's also moving. So, well, Yeah, shut up. Where's your slope angles? How come you're not using slope angles? I want to know why you're not using slope angles. It's like, it's clearly doing this. That's what it's going to do consistently. Where are your slope angles? As simple as it can get, brute force it, do better. Meanwhile, the other side, dimensional stuff, that big sphere thingy, whatever, as things come in, has other spheres, you know what I mean, of less and greater amounts of knowledge, right? So it's like, I can observe about this good for these things at these distances, right? That's about as good as I can get. It sure would be nice if that uncertainty that way, over there, really far, that I cannot possibly at all observe well, could be managed to be better. Problem is not going to get solved anytime soon. So, yep, that one sucks. Until they're willing to go through and do all the fucking reprogramming and mathematics changes and more. I mean, this literally rewrites pi math. You know what I mean? It rewrites velocity math. It turns a relativity problem into anything, basically. And then you have to observe it, and then observe it while you're going with it. Okay? So you have to go with the flow and observe effectively. And so it, instead of entanglement here, is just a part of the thing. So it's like, hey, this particle that we know that we're introducing is going along with this, and then we'll receive it over here, kind of like spies do. And then they'll have done this information back and forth with what's around, and then we'll see what the changes are in a local, real environment, which destroys the Bell experiment and makes it so, guess what? You can break Heisenberg's uncertainty principle. And that's a good thing, actually. Because when you do that, you go, well, we are moving, and our satellite's moving, and all of our telescopes are moving, and we can account for these things that are moving, like this. And then roughly this interstellar media, intergalactic media, and so on, is like this. And so as we continue, pushing something out and then putting it back in, so we're going, hey, go out there, and then come back, you know what I mean? Like, mass, light, plasma, particles, whatever, We get the understanding, finally, that we can go, this was influenced like this. And it's like, all right, well, we know that this big ejection from such and such time back then, 100-something years ago, should be arriving roughly around like this. It's like, my neutrons! No, not my neutrons! Not the fucking already known data we have that we could use like this. Why didn't we? The vertice of slope. Why didn't we know the influential value of neutrons? Because those are kind of hard. Instead, let's go with like this. This is charged particles that come in. Because, we'd love neutrons, but we don't detect them very easily or very well. They kind of suck like that. They do. You know what I mean? Right? And so we're like, okay, how about charged particles? How about photon emissions? How about light emittance and virtual states and ionic states? As they will absolutely change, like I said in multiple videos, over time to arrive to you. Why not do that? Why not, hey, this vibration of my sensor and the information that changes because of the heat and that physical phononic, along with the intersecting interferences of side and diagonal and more light waves and, all these particles too, then influence it along the way to the sensor, which the sensor itself also has going through it. You do have to account for all those things. It's like, that's insanely very high amounts of all this data we already have that we'd have to calculate for. I would not like that. That would be very not cool. Do the work. Here's a slope angle. Oh no! Your angles of these given energy changes with these interferences with the UNRWA. Oh, here's a little radiation, bro. Different particles spin off, vortice, collapse, expand. Oh no, my quantum foam is absolutely able to be understood. The fluid is able to be known, man. You just gotta do the initial work. No, I'd rather that's you shut up over there, okay? I'd rather I'd rather do the work. Oh, well, we got one that's not with them. Good. That's what I've been talking about. It's like here. This is one of the reasons why I can tunnel information as a quantum superpositional tunnel transistor. Why? It retains the information and calculates and changes. Why? It becomes doable at room temperature without superconducting materials. Why? Basically everything around you can do that at all times. But not everything is, obviously. Isn't that a funny one? Anyways, there's that. That's the pi math.
Alrighty, so I'm back home. This will be already, but this is to basically just say that, hey, so why don't we just, do instead of one ginormous rod, and we try and calculate the slope angle for pi here, we do multiples. And then we connect them together. And then we make the entirety of the circle. And then we go, nope, none of those rods are there. That's all I'm going to be saying. But it actually relates to other things with quantum tensor, geometry, dimensional movement stuff, light, and how it's a whole thing. So, yeah, stick around.